Welcome back to the workshop, and welcome to this continuing series to improve this drill press by adding a bit more clearance underneath the chuck and adding a motorised knee lift. So to make more space, I'm going to trim back these triangular side pieces here, one on each side and then the back piece as well. And then we're basically going to replace this kind of clamp system in the middle, and that's where the ball screw will go, which will lift the table up and down. And in the last episode you saw me swap out the DC motor for this stepper motor here and then modify the drive system with this tensioner. So that's kind of where we got to with this. I don't think we can do any more on this for now. This assembly will ultimately go underneath the knee itself, and then the ball nut will go in here and the ball screw through there. But the ball screw is currently in the back of the machine, so I think we need to start disassembling and take that out. So I think where we're going to start, there's a ball screw at the back there that drives the knee up and down. So we'll take the handle off there. It's got like a bevel pinion that turns it through 90 degrees. And then I think we can undo some screws down here that hold the bottom of that ball screw in. And then hopefully we can get it out. I'm trying to remember exactly what was holding it in, but we'll take it piece by piece. And hopefully we can get that out. Now I think to make access easier, I'm just going to take this bellows or sort of cover off here so we can get in from this end. And then I think we'll drop the knee down as low as it can go. Yeah, okay, let's start by taking this one off. Now I've got a feeling that where the ball nut goes up here, it goes into the bearing block for that, and it's somewhere behind here. So I might have to take this off, this whole block, to get to it, but if we take this off, it should give us a better view. And thank you for all your comments so far on this. I think there's quite a theme of isn't it overkill? I just added this little motor and it goes up and down, or did this, whatever. Yeah, I tend to get into these projects and make them more complicated than perhaps they need to be. I kind of enjoy it, so maybe that's why I end up doing it like that. But if I just knock something together in an hour, I'd probably be very bored. Yeah, quite like it. I don't mind the fact it takes a long time, as long as I've got a plan and I know where I'm heading. And I plan each stage out, hopefully draw it all up in CAD so there's no surprises, or limited number of surprises anyway. And then sort of try and make it look, wrong size. Make it look nice as well. So it's when you come into the workshop, you actually want to get into using that machine. And I think on this one, maybe I'm going overboard with the approach, having to write code. But it's quite fun. I quite enjoy the challenge. And I might never use quite a load of the features, but who knows? Who knows? Okay, so you can see the ball nut down there, and then it mounts onto this really large block that is in turn bolted on there via those 6 fixings. So if we take those out, that big block that goes rearward, that's this one, will come off. I think I'll take these out first, then undo the blocks. We've got that. Then we can get to the handle, get the drive shaft out. It's got the gear on the end. The whole thing should come out as one. And then yes, I forgot about that. So I actually added this access plate to get to the gearbox, I suppose you might call it. That might give me access to the top of the ball nut that holds the end of the ball screw. Alright, so we'll see. Maybe this will come down enough, I don't know. The other end of that fixing. That's quite big. Alright, one step at a time. Let's get this ball nut off. So it might be a while before this goes back together. So I'll just bag everything up. It's a bit easier because some of these fixings are very similar, but maybe different lengths throughout the machine. I was thinking of taking the handle off. I think that will be okay. I've got some ball-ended ones of these as well, but I think this might just do it. should come out now. Oh yeah. Okay, so inside there, that's the other bevel gear, that's the top of the ball screws, and I think the little bolts that hold that on are just behind here, so yeah, this is going to have to come off next to get to this panel. Not really been super happy with this light. It's quite, it's right at the back here, it's not super bright. I might upgrade it, have some kind of ring light around here, be a lot better. And hopefully that will thread through there. Maybe it won't. No, I think it'd have to be, I must have threaded it through like that. Okay, we'll take it off. That doesn't go back through there, does it? No, because obviously it's got a flange on that's wider. I'm just going to see if I can get any access without taking this off, because I remember it was a bit of a pain just aligning that, so it definitely ran nice and true in line with the quill there, and getting the digital readout on this side all lined up as well, running nice and smooth. So loosen this and the whole thing should come off. Alright, so the bolt that came out there, I turned it around but wasn't long enough to go through the threads this way to act as a jack screw to push it apart, so I've just got a longer one, put a washer in there, and that's now pushing up against that, so that should open it out, and hopefully make it, oh yeah, make it a bit looser. And it's off. I've just made a bit of space over here. That's perfect. Okay. Okay, now it's a bit easier to see what we've got, so I think what I'll do is take the bevel gear off, undo that nut, then loosen these bolts here. Same on the ball nut down there. You see, yeah, ball nut down there. And then at the other end, there's a support at the lower end, which I think is accessible through probably this upper pair here. So I'll take those bolts out, and that will be the lower end of the ball screw. And then that should, I think if I drop it down, oh yeah, I've got to loosen it off here as well, haven't I? I've got to loosen those 6 back there which hold the block on, and then that should do it. So this is going to be a bit awkward to film, so I'll just get on with it and let's get that out. Well, a bit of an update. I went in last night to edit that last couple of hours of footage together, and unfortunately quite a lot of it was sort of wobbly like this. Never had that happen before, so I don't know why it's doing that. But anyway, it's an old iPhone SE, so what's that, 5 or a 7? Maybe a 7, I think. Anyway, I mean, it's a pretty ancient phone. The battery's had it. You have to have it constantly plugged in on a power cable to do any kind of filming or do anything with it, to be honest. So it's not really a mobile phone anymore. If anyone's got any ideas why that went wobbly. It is a bit cold in the garage. It's about, what's it today, 18 today, so yesterday would have been similar. Who knows? Anyway, so I lost a bit of footage because you probably don't want to watch endless wobbly video. It doesn't look very good, does it? Okay, so now we've got it stripped down to this level. You can sort of see what's going on behind the scenes here. So we've got our main plate there. I've paused here for a minute because I'm just thinking about, you know, the sequence here and whether to take this apart, or because I've got the Z-axis DRL on the back there, and I know I needed to make a super long bracket that goes around to that. maybe, because I'm not using the ball screw anymore, I can do an easier one from this side, and maybe I should leave it in place just for now. So you can see the big bracket here, it's about that deep. That runs quite thick, further than my finger can reach. There's a big chunky bracket there. Obviously I don't need that anymore because I'm not going to be driving it from the back. I'm going to be driving it direct from underneath here and lifting it with the ball screw here. And that's got a little bracket off it that goes to the read head, and then you may be able to see it just running up and down here. That's the Z-axis readout, so it knows where the table is. So there's a couple of options. One is, so if I keep this in place, then I know that spacing's right, because you need about 1mm space there, and I can make up a new bracket from here, because the problem I've got is, because this is now going to move a lot more, this will run out of travel, so I'll have to take this off. So I've got to make another way of getting from here to there, and I was going to come up, because this is going to go down a lot further, sort of have a bracket that comes up, back and drops down, but it's all a bit fiddly because it's all behind here to try and adjust it. So the other option is to bring a bracket out from the triangular plate and go rearward, sort of come round from this way, and in there. And then the third option is to take the readout off the back of here and actually put it on the side, because I haven't got the handle in the way or any of that mechanism anymore, and then the connection be a little easier. As you can see the DRO there, so it's quite long. It starts there and goes down to the bottom. Because I'm not using this handle anymore, I can use this space. I could actually mount this basically on the side here. Yeah, so then I can make, if the read head goes up and down there, I can make a bracket that comes off here and picks up off the read head that's sort of about there, and then the DRO is about there. There is a bit of a bracket here on the main table. I'd have to just trim that back a bit, but that's no big deal. So I'm quite tempted to do that. Then yeah, I can still align it, can't I? Because I need to be able to bring it in and out in that sense. So we'll probably have to put some packing shims underneath it to get it aligned that way. Backwards and forwards, that's okay because it'll be on slots. So thinking of the three options there anyway for the readout. So the part that holds the ball screw on is this bit here, and this is what I originally drew as per the drawing there, and I decided I'm just going to put a little counter bore in that side there. So I'll have a screw comes from the top, I think it's an M8 countersink, and I'll put a little counter bore in there, and then this is the ball screw as it currently is. So you probably recognise it from CNC machine style, so you've got your supported bearing at that end and then the driven end up here. Now I need this to be not have this driven end because this is all going to be fixed, and then the ball nut will rotate. I'll just check the dimension. I need it to be 315 long, which luckily I've got enough left, so let's say 315 there at that end. Takes me to about here somewhere, so I'll crop that off, and then I've just got machine a little boss on the end of that, or a little recess, and then that's what will sit into that pocket that I'm going to machine into there, and then the end will be drilled and tapped for M8, and that will hold that on. So this will go on to the table, and that'll just hold it in position. And then these holes are oversized so I can get it slightly aligned, so I'll sit on there and push it up and down. So we need to do that. So we need to modify that part to put that little counter bore in, modify this to length, and then on that end there, to make sure I don't drive it all the way out and have all the balls fall out. You know, if I lifted the table up really high, there'll be a locking collar, and that's over there. So I'll just sit on there, and that'll just be a little grub screw, just lock it off and prevent it from being able to go up any further into there. So we need to get all those things done, get that stripped down. Not that exciting, so I'll just get all that sorted out and then bring you back when it's done. Okay, so our ball screw is modified now. So at this end, I've just filed a little flat, and that'll be where the retaining collar goes on for the grub screw. And then this end, shortened it down, put that little stub on there, so that will fit into the pocket in there, and then just tap the end M8, and that'll be a retaining screw. So I'll machine that counter bore in there. That drops on there, and that goes on there, and then that in turn will bolt up onto the underside of the table from this end, and then that'll push it up and down. So we've got that bit done. And then the bit I've got down here, that's the locking collar. Just got it in some white spirit terps. Wilco, unfortunately no longer with us. There's a high street brand, another one gone. Anyway, so we've got that in there, cleaning that, and then we'll cold blue it, because that's steel. And hopefully, because that will live down the bottom here most of the time, and yeah, it might start rusting, so that might give it a little bit more protection. So we'll get that sorted out, get that in there, and then while that's bluing, we'll get the ball screw on now. That plastic collar might be a bit tight over there, I don't know, we'll see. And I've just filed the bit there where it's been machined on the lathe to try and get that, you know, the balls to go in. I don't know, still feels like it might catch a bit, we'll see. I'll give it a go. But anyway, let's get that blued up, and then we'll get this on next. Okay, I've just washed the locking collar to stop the reaction, and then just put it in some oil. I think it opens the pores up a little bit, and some of the oil sinks in. It's not perfect, a few little blotches, but alright, might hold the rust at bay. Okay, now the part I don't normally look forward to, just getting these back on, especially as I've machined the end of this, so it just depends how it gets on with that bit of thread in the start there. In fact, what I'll do, I'll rotate that part around so it's at the top. So there. Then down here I've got my little catcher, just in case any of the balls come out, they'll drop into here. Now, I've learned from experience, if you just have a plastic box, they can just bounce out and you'll never see them again, so I've just got this little rag in there. Normally, if you do this, that means they won't come out. If you don't, then they will. That's how it works. So, it needs to go on, this way. Okay. I'll put those in there. It's a bit of counterweight. Yeah, it's kind of hung over the edge a bit. Oh, that might go on. Alright, let's just keep the pressure on. Hopefully this will go on first time. Oh no. That feels encouraging. No. No. Okay, take two. If it doesn't go, I might take the seal out. That's basically what's winding on now. Alright, so the seal's on. Now for the first ball. Okay, well, I haven't taken the seal out, I've just loosened the grub screws. That'll allow the seal to rotate independently. It might be that it's moved around a bit and it's no longer lined up. Hopefully it's simple as that. Here we go, take three. I wonder if just the thread needs a little bit more filing. No, it's not happy. Right. I'll dress that thread a bit and then we'll bring you back. Okay, I'll try that again. Nope. Okay, I've dressed up the thread a bit more. I put a little bit of the ball screw grease on there. Shouldn't really be necessary, but it might just help it along. Now, oh, come on. I think we got it. There's a temp number 6, I think, there. Lost count. Yeah, it's basically I just needed to file the bit that had been turned, and it had raised a little bit of a burr. Of course, this is a little bit hardened on the outer part of the thread, so the file wasn't cutting as much as I thought, so it took a few goes. Anyway, it's on. Right, let's tidy that up. I was wondering why that seal wouldn't go into there, and I noticed there's already a seal, and then I noticed I put it on backwards. Right, coffee. Right, by the magic of YouTube, it will now be the right way around. Okay, now it's on, and it's the right way around, and the seal's dropped in as it should. So we'll just get the two world's most smallest grub screws into that, and the second one. Okay, the last thing to do is get our locking collar on. Just try and get it to line up with the flap. Yeah, somewhere there. Okay, one ball screw machined and ready to go. Okay, I think next we'll take this ball nut block out, because we don't need that in the new design. So it's just held on by I think 6 cap head screws under here. Okay. Took me ages to make that, but anyway. Don't need it now. Okay, so before we take that rod out there, we'll lower it down onto the base there, and then we can mark a hole, because that's where the ball screw's got to go through, and we'll drill a hole through here and through the top here, the tabletop, and that will allow the ball screw to pass all the way underneath and into the space underneath. And then we should be able to put the motor on here and give it a trial run, at least lifting this quite lightweight bit up, and make sure that works before we go any further. Right, let's do that next. Careful I don't run out off the end of these rails. I think we're going to be okay. Right, well, I've just brought everything over just to give a trial fit, and then we were just going to make sure it definitely move up and down. Mixed news. Good news is the stepper's motor's going to clear the base, which I was a bit worried about that, and it clears the table, so that's fine. However, that spacing in there does not match the bolt pattern in the nut plates that are underneath there, so it doesn't fit. So looking back at the part that was in there, it looks like I've got slotted holes, whereas in CAD they were just single holes, and I've replicated that hole pattern on this mounting plate on here, and clearly that is not going to fit. So to give you an idea, that one's in about the right position, and that's in the thread, but I don't know if you can see there, it's quite a bit out this side. It needs to go in, I don't know, maybe 8mm, something like that. So I think what I'm going to do is dismantle this. I think, yeah, I can push that out, dismantle this, take the stepper off, get this on CNC machine, line up on those slots, fun, and open them out. Show you, I need to come inboard, don't I? So if I come inboard 10mm on each one, that should be enough, and then it will re-centralise the plate. Now it will mean these blocks tuck under, so they're not flush with the edge, but they'll be equal both sides, and you know, that will be fine. Just thinking if there's another option. No, I think that'll be best, because otherwise, you know, if I drill some new holes or make some new plates under there, then these blocks will be half on and half off this material. They won't sit astride the slot, so I think that's what we're going to do. But for now, we'll get one of them tightened up and just make sure, you know, for fun, it's definitely going to work. Okay, I'll switch on. Turn the speed down. Alright, let's see what happens. Now it's only loose on there, so it might kick around a bit. In fact, I'll just hold it. Okay, down. Alright, what's full speed look like? Oops, it's making a bumping noise. I think the ball nut's clicking in there. It's not quite aligned. That's maximum, so by the time we got the table on there, so it's about 150 to the top of the table, which is the, okay, let's go down. Oh, I think the table's staying there. Oh, is it? Oh no. Okay, let's go down. Something's not moving. Ah, see. Okay, the whole thing's spinning because that's not bolted in up there. Yeah, that's what's happening there. Alright, I've just loosely screwed the plate to this because essentially the whole thing was spinning and it wasn't actually going down. Hopefully this will work. Going down. Sounds quite smooth. Is that the fastest we can go? Somewhere there. Alright, go with that. Okay, we've got the part set up, ready to do those slots. Now, I got a bit lucky here because the last part machined out was actually this one. You can see the little witness mark around the edge, so I was able to line that up. And I should be able to find the CNC code to see where the actual 0 was, the local 0 here. And then you can see the coordinates I need to go to machine that slot out. I've just written them on there. So it's a 6mm end mill, and that's an 8mm wide slot, so we'll just move over 1mm each side to clean that up. And then I've covered up the bearing because I don't really want to press that out again, so that should just stop the swarf getting in. Right, let's cut this out, and then once I've done that, I'll see you back at the machine. Okay, we've got the plate machined out, got those slots in there, and as you can see, we're starting to put it back together. Actually, these slots have done me a favour because what it will allow me to do is get this lined up nicely with the table, so I can kind of wiggle it about a bit and get it nicely centralised. So I think the next thing we'll do then, let's get the ball screw in. For a minute there I was thinking, oh, where should I put the grease nipple so I've got best access? Thinking of like on my CNC machine, but of course this spins around, so yeah, that doesn't make any difference. Alright. Okay, I've just got it loosely bolted together, reasonably aligned, so let me show you it in action. So we got it set on about 3/4 speed, so we'll going up. Does sound quite smooth, doesn't it? Going down. Let's see how fast we can go going up. That's 76, 80 arbitrary units, 80. Now I think it'll start to stall out in a minute. 85, yeah. Okay, still going. 90. Okay, let's go full 96. Alright, somewhere there. About 90. Of course, when I have the XY table on, it's going to load it up, so we'll see how we get on with that. As I said earlier in the video, if I really struggle, it's only putting out 27 volts. In theory, I can go somewhere close to 50 volts with that, and it'll easily give me loads more torque. But it means buying another power supply, so we'll see. Let's go with it. 90. Yeah, let's try again. 80, somewhere around there is probably full. You certainly can't stop it. Yeah, that's nice. Okay, I'm really pleased with the progress so far. That's really good. Yes, it sounds nice and smooth. It's going up and down. Doesn't sound strained. Might need to up the voltage a little bit. We'll see how it goes when we put the XY table on and see if I want to run it up and down any faster. But that's progress. I'm really happy with that. And as I've mentioned in earlier videos, the microprocessor allows me to do custom things like can drill cycles or a whole load of different things. Or to be honest, I might just end up going up and down like that. Anyway, it gives me options, and I'm quite enjoying this so far. Okay, I think that's it for this video. In the next one, we'll actually start tearing it down even further, because both these sides have got to come off and the back plate got to come off, because these have got to be cut about here. And then the back plate as well, probably take about that much off it. So it's all have to come out, be marked up, go on the CNC machine and trim it to size. Then it can all get reassembled. Now when I put this together, I put like a dial indicator on here and got this really true to the axis of the chuck. So I'll need to do that again, get it all lined up again. And I think while it's off, I'll probably need to drill and tap for the fixings that end up driving the digital readout, because I think I'm going to put it on the side here. Allows me to put the micro switches on there as well, so that'll be a little bit easier. But we'll have a look at all that in the next video. So hope you've enjoyed watching. If you're interested in this, feel free to subscribe, and see you next time.